Now we turn to our first debate on moving towards a circular economy. The European Commission has emphasised that one of the key elements to reaching climate neutrality is to decrease reliance on primary materials and move towards more reuse and recycling. To discuss how waste energy contributes to this, I'm joined by Piotr, who is Senior Policy Officer for Waste at the European Environmental Bureau. He's online. And Stengler, with me in the studio, the Managing Director of the Confederation of European Waste-to-Energy Plants. Thank you both for joining us. Now, I believe each of you will give a short presentation and then we'll move on to some questions. So, Piotr, you have the floor. Would you like to give your presentation, please?
Thank you, Kira, and good afternoon to everyone. I hope you can hear me, and I have a presentation, so please, I ask the technicians to put it on. So yes, my name is Piotr Barczak, and I thank you for this invitation. I've been working on the EEB, European Environmental Bureau, for many years already, covering all the waste policies, including the advocacy on the Waste Framework Directive and other waste directives. Please, next slide. First of all, I wanted to just clarify the definition. Waste to energy, as it is, next slide, please. It is mentioned here often. For me, it is a broad concept. It is not only about incineration. It is also about anaerobic digestion. So the fermentation of organic waste, which gives us biomethane. And if it comes, of course, it has to come from bio-waste sources, which are clean. This waste later on, after stabilization, can be used again in the circular economies. In this graph, from resources extraction and imports, because Europe is poor in resources, but also to cut from the leakage of materials, which is incineration with energy recovery or not, and landfilling. Next slide, please. And this has been a goal of the European policies for many years already, together with the first circular economy package in 2015, and actually before, and continuing even now. This has been the aim. Our aim is to increase recycling up to at least 65% in the next decade, or 70% in packaging. But this is just the minimum. But there are other very important new rules that are, in fact, in contradiction with the push to burning more waste, which is mandatory separate collection of certain streams, any other actually mandatory streams, mandatory separate collection. Also, there is a ban on incineration and landfilling of separately collected waste. There are also, next slide, please, new rules calling for stringent EPR rules, so that all producers will have to be responsible and put as much funding in order to recover their waste, recover the materials contained in that product that they're produced and put on the market at the end of life, instead of just putting them in the landfill or in the incinerator to burn. In 2020, we had the second circular economy action plan, which is even more stringent in terms of circular economy, even more looking at the way how we design products. So if the Commission goes ahead, and they do go ahead with their very ambitious eco-design rules, we will have less and less difficult products, difficult to recycle. So this stream will definitely will go down. There are also rules to ensure less waste generated and cut residual waste. Please, next slide. Such as also food waste. There will be a goal to cut by half food waste. But very important for this discussion today is a goal that by 2030 we will have to cut the amount of residual waste, so non-recycled waste, by 50%. So just take the number today and cut it by 2 in 8 years from now. Of course, to that goal, there will be different activities, legislative new initiatives such as eco-design, such as also essential requirements for packaging and other streams, plastics, textiles, also industrial waste. So that's it. These are the goals, and this is very important to bear in mind. That no other policies, no other decisions, be it at national level or European level or local level, should not contradict this major goal that is there. There will be further actions on reducing single-use items, and single-use items basically. But I wanted to zoom into our mixed waste bin. This is a report done by RAP, it's a government organization in UK, who they look at what is contained in our mixed bin, and it's large. UK has a large bin, and many other countries too. And when we look inside what is considered to be non-recyclable, which is mixed waste, actually, when we look at the materials in it, the products in it, we see that more than half of it could be readily recyclable already today with the current technologies. Another quarter of the bin could be potentially recyclable because the technologies of recycling, of sorting, are also very much improving. Then there are groups that could be substituted. So in the end, next slide, we will have very little still amount of truly unrecyclable waste. This graph shows you in kilograms per person. So if we actually add the difficult to recycle or substitute materials, we would have up to 50 kilograms of residual waste per person. And that is, even if we go very accurately, only 20 kilograms per person of difficult to recycle waste. And that is the goal. So actually, when planning the capacity for residual waste treatment, we should not go beyond, I would say, those 20, or if we want to be a bit more, less conservative, let's go to 50 kilograms per person. But that's maximum. Today, many countries, they have their capacities put at 200 or even more kilograms per person, such as Denmark. And many countries are going this direction, unfortunately. So next slide. The best strategy. This is another example, very precise from Italy. When we show in Italy, in one of the regions or municipalities that is called Capanori, where they have quite well performing separate waste collection. And what we see that even in the residual bin there, we have about half of it that could be still recyclable. So very much showing the same what the UK study showed. Very interesting is that even 13, almost 14% of that bin are the nappies. And we know there are solutions for single-use nappies. There are difficult today, those single-use nappies today, but there are solutions. There are substitutes, such as reusable nappies, and that is what many different NGOs are calling across Europe. And this is really readily available and easy to use. So next slide, please. This takes me to a conclusion that the best way to address residual waste and incineration and landfilling in the same time is to put a cap on waste generated. Prevention has not been very high on the agenda, unfortunately, by the European legislation, but that is going to change. As I said, there are prevention goals going to be revised in 2024, and already now the Commission has announced, number 10, please, slide, and the Commission has announced already that that by 2030 we need to reduce residual waste by 30%. And if we have targets, the policies prove to be effective, and countries are in majority following them, and then we have results. Without previous targets on waste prevention, we didn't have any achievements. That's clear, but there are going to change. Next slide, number 10, please. So that next one. So now going a bit to data. Oh, these are very small numbers. I'm sorry, but this comes from the report by Tomra and Eunomia. It shows just compares two ways of treating residual waste. Either we go like it is going to it is being done today, straight to incineration. So we take residual waste and they are sent to incineration, which generates a lot of CO2. And actually my colleague from Zero Waste Europe in the next session will speak a lot about this. So incineration is a huge emitter of CO2, as compared to another scenario where before putting residual waste into the residual waste treatment, being it waste incineration, there is much more advanced sorting happening, and there are new advanced techniques such as hot wash and color sorting. It is going much better. Apart from all the facts that I said before, that we are going to have much better designed products because of eco-design and essential requirements for packaging and much more stringent separate collection, residual waste is going to be smaller. But even if we still have residual waste, before going straight to incineration, we have to sort residual waste again to stabilize the bio-waste fraction, which is still contained, as I showed you from the Italian example, up to 16% of residual waste is still bio-waste, which is perfectly recyclable. So one way is to stabilize and therefore minimize the methane emissions from landfilling. And very often this argument is brought by waste incineration promoters, methane from landfilling. But this is going to reduce also maximally, because what is the reason of methane on the landfills is the bio-waste. We have, in next year, we will have mandatory bio-waste separate collection 100% for all of the countries. Even if some fraction will still be in the residual waste bin, it is going to be stabilized. So that's on the bio-waste part. But on the recyclables part, much more advanced sorting through MRBT, so mechanical material recovery and biological stabilization techniques. We are going to extract even more metals and gold, as it is compared to incineration, from those residual streams done from residual ashes from waste incineration. And on top of that, we are going to emit less CO2 emissions, much less CO2 emissions as compared, as shown in this report. Next slide, please. So, yeah, just not to forget the issue about jobs creation. Incineration is not creating jobs. They are working full-time on few shifts, but it's really just few persons. Recently I visited the Vienna incineration plant, and there are like 8, maybe around 10 persons working there. So it is very effective in terms of labor, but it does not create jobs and value, that the jobs that are coming from the value of materials that would otherwise be recycled or through reuse. Next slide. And really very important, we are in a climate crisis. We have kids on the streets. We have no margin left to build any new CO2 emitters, any new either coal or gas or waste incinerators that we will have for next decades, because this infrastructure is expensive and it takes a lot of resources to be paid back. So no, if we really speak honestly about climate neutrality and CO2 reduction, there is no room for more plants that emit CO2 in the atmosphere. Next slide. There are few very good reports that say what to do about residuals, and really it's very important to know that waste incineration, or let's call it burning waste incineration, it's not the only way to treat residual waste. And really, it's the most expensive. As we compare incineration with capex around 1,000 euro per ton installed to MRBT that I mentioned before, that is between 200 and 400 euro per ton installed. That is much less expensive for MRBT. So if we use public funds, and all of this is public funds, either it's EU, which actually is going to be not possible to access anymore because of taxonomy, but if it's local and national funds, it is also not, waste incineration is not the most intelligent way to use public resources. Next slide. Actually, I almost finished now. I invite you to check this report by Zero Waste Europe, and I know Yannick will explore more about this in the next panel. So next slide. So just about some solutions really here. We, with the European Green Deal, when we look at the objective of having products sustainable as a norm, we have to use all those economic incentives as well. And EPR, modulation of EPR towards eco-design is really helping here. There is much more deposit return systems being deployed around Europe for different packaging streams, and maybe why not also to other streams. There are green certificates and taxing incineration. I would say if there is a role of incineration to play in circular economy, there is one role. I can say that there is a role, which means increasing the gate fees so that to disincentivize this activity in view of the municipalities that have to choose either they're sent more to recycling and composting, or they will have to face very high taxes when putting their waste on landfill or in incineration. For this also there is ETS that is going to play a role. Of course, we have other incentives, economic incentives to increase separate collection, which is important. And as I said, it's mandatory for many streams. And also to boost recycling market. And many could criticize why recycling market is not working properly. It is because in the public funding, we don't prioritize recycled content yet as much as we should. European Green Deal and the Circular Economy Action Plan has this objective. So these are the tools that really will help us to go towards circular economy and reduce the amount of residual waste still present. Next slide. Well, this is just some more resources for you to get. I get you will get the PDF later on. And yes, we have ambitious directives in European Union, but how are they implemented? I agree, it is not easy at national level very often, but there are good examples. And here in those materials, we gather best examples of different legislations across Europe, sometimes even at city level, that boost waste prevention, reuse, and separate collection. So there is no need to reinvent the wheel. There is no reason to cry and say that we will still have tons and tons of residual waste. It is going to be reduced much if only political will be, if only there will be a political will. So up to the next or the last slide, which is my contact details. Yeah, I'm sorry for those problems, but if I can reply any questions still, I would gladly do.
So yes, I will talk. I hope I can be heard now. I will talk about the double role of waste to energy. First of all, the essential task of waste to energy is a hygienic one. Sounds strange. Waste to energy treats the sorry.
I think we've got a bit of trouble with the feedback in the studio at the moment.
Too much echo.
Okay, please keep going if you can.
Should I?
Yeah.
Okay. For me, it sounds good now. Okay, so first task is a hygienic task to treat the pollutants embedded in the waste in a hygienic waste, acting as a pollutant sink, avoiding that pollutants are spread into the material cycle. Secondly, waste-to-energy operators try to generate as much energy as possible embedded in the waste and also create secondary raw materials, for example, from the bottom ash, where, for instance, metals can be recycled. Next slide, please. We very much support the waste hierarchy, which means prevention first, and then prevention and reuse, followed by recycling. And in order to achieve quality recycling, as I still think quality matters even more as just quantity, in order to achieve quality recycle, we need source separation, effective source separation, so that the materials are kept clean. Once they are mixed, it's difficult to recycle it into quality products. So source separation is really, really key. And that also makes sure that only the non-recyclable waste goes into the next step in the waste hierarchy, for instance, into energy recovery. Next step, please. Next slide. Can't we recycle everything? Not now. So there are still dirty, mixed and contaminated materials in the waste. Also, after several circles of recycling, the material gets degraded, so you cannot produce quality products any longer. And there are materials containing substances of concern which are even not allowed to be recycled. So these are currently the limits of recycling, and that's where waste to energy can come in. Next slide, please. So in the recycling process, articles that contain substances of concern can contaminate the respective waste streams. And according to modeling studies undertaken by the European Commission, it may take centuries to decontaminate a recycled waste stream. And this is why, time matters. And as long as we still produce these materials, which are difficult to recycle, we rely, and we can rely on waste to energy to deal with these difficult materials. Next slide, please. Next slide, you can skip this. And this is a graph that we update every year. It's based on Eurostat figures, and it shows the green bar is recycling in the member states, the yellow is waste to energy, and it shows that in member states where you achieve rather high recycling rates, they also rely on waste to energy, because waste to energy is needed to treat the rejects from sorting and recycling facilities. So the one goes hand in hand with the other. And you see that these member states on the left side also don't rely on landfilling anymore, whereas on the right side, the member states, that's the red bar, which landfill still a lot, they also achieve low recycling rates and have practically no waste to energy. So again and again, the conclusion is every year confirmed that waste to energy and recycling go hand in hand in order to divert waste from landfills. And also waste to energy contributes to quality recycling because it is a reliable treatment for the rejects from recycling facilities. Next slide, please. And it's also in line with the waste hierarchy to try to reduce as much as possible landfilling of waste that can be recycled or recovered. And this protects soil and groundwater from potential contamination. It also saves space, which is quite rare in Europe. It prevents microplastics being blown by the wind to water bodies. And of course, it harnesses the material and energy content of residual waste. And it also avoids the creation of greenhouse gases, because methane, which is emitted from landfills, is a very potent greenhouse gas in comparison to CO2, normal CO2 in mass. And we always say it's about 28 times more potent than normal CO2. But if you would look at methane emissions from landfills, not only in a 100-year perspective, but in a 20 years perspective, then methane is even more than 80 times more potential than normal CO2. And this is why in a recent UN report, they recommend to look into a 20 years perspective rather than a 100 years perspective when it comes to methane emissions, because we are quite in an emergency case with climate. Next case, slide please. And reducing greenhouse gases is in the waste management sector. Their diversion from landfill is a main contribution to greenhouse gas mitigation. And this is a quote from the German Environmental Protection Agency, which did some calculations back to 2015, but it's still valid. We have a huge potential to reduce methane emissions from landfills if you divert waste that can be recycled or recovered from landfills. There's always still something left which can't be recovered or recycled, but and needs to be landfilled. But what can go higher up the hierarchy, that should be treated higher up the hierarchy. Next slide, please. To conclude, what is waste to energy's double role? It contributes to sustainable waste management, as well as to energy and climate policy. First of all, the hygienic task, but additionally it substitutes fossil fuels by producing the energy embedded in the waste, and it helps us also to become less dependent on fossil fuel imports. And it is a local energy source, and it is affordable because the waste needs to be treated anyway. And additionally, it helps, together with recycling, to divert waste from landfills, avoiding methane emissions. And last but not least, waste to energy recovers valuable materials from the bottom ash, which is the remaining part after the incineration process. And via, next slide please, and via recycling of metals from bottom ash, for instance, there's in 1 ton of bottom ash, there's about 10% of metals. And if you recycle them, then you can save per ton of recycled metals about 2 tons of CO2 emissions. And in Europe, it's about 3 million tons of CO2 equivalent emissions that are saved with metal recycling from the bottom ash. And the remaining part, that's the mineral part of the bottom ash that can be used for construction purposes. You see here on the slide a brick which is used for construction purposes. And last slide, please, to finish. Another thing that is more and more explored, and Patrick mentioned it in the introduction, that is hydrogen production. So if you have excess energy, you can put it into an electrolyzer and produce hydrogen. And for example, in Wuppertal, there are city buses fueled by this hydrogen produced by the Wuppertal waste-to-energy plant, and it replaces diesel. So the city buses run by hydrogen and contribute to clean public transport.
Maybe we can turn to Ella for our first question. Reaching a circular economy is essential for the green transition. What will it take to close the loop and ensure material is recovered? What role do you see waste-to-energy playing there?
I agree that recyclable waste and materials should not enter waste-to-energy. It is there for the waste that is difficult. So Piotr mentioned it already, eco-design is very important in order to avoid that we have too many materials which cannot be recycled. But this will take time. And until we reach this status, we should rely on waste-to-energy as a sustainable way to treat this residual waste, closing the loop.
So is it something you see as continuing to be used? Because presumably as more residual waste is cut down, there'll be less resources for waste-to-energy to burn.
In a perfect world, we would produce 0 residual waste, and then, then indeed you're right. Then waste-to-energy would be not necessary. But unfortunately, we are not in an ideal world, and we are still producing residual waste. And so far, our society was not very successful to reduce our waste generation in Europe, and worldwide predictions go even up. So we should indeed do a lot of efforts to reduce our waste generation. It all goes along with effective eco-design. But as long as we are not there, I think we should be happy to have a reliable treatment for that.
And you talked a lot about how recovery is done within waste-to-energy plants. I think there is still a certain extent where people hear waste-to-energy and just think of incineration and that there is material lost. How much material is actually lost and what can be recovered? And do you think waste-to-energy needs sort of a shift in how people see it?
Yeah, the shift would be indeed good in the way to people recognize the efforts the waste-to-energy operators are doing to do the best with the leftover, which nobody wants to. It's not that waste-to-energy operators are chasing to get waste into their ovens. It is that it is really the residual part which nobody can do anything better with and wants to get rid of. So, and then of course you should try to produce as much as energy out of it, but also you can still take some materials out of it, as I just mentioned, the metal recycling from the bottom ashes.
And I know we hear a lot from maybe the recycling industry that they actually need a stronger secondary raw materials market. Is that something that you think also needs to happen?
Yes, definitely. I think we need some incentives there. I see it also with bottom ash. So using bottom ash more in construction works would also help. So incentives to use more recycled materials would be definitely good. A market would be good as well, and we need to develop that market. But what is key in order to achieve a workable market is quality. So quality really matters.
And I guess the criticism would be, well, actually, if you have all of these waste-to-energy plants, then presumably you do need quantity as well, because they all need to keep going. Is that something which is an issue for you?
It is not an issue for now, because now we still produce more waste than the European waste-to-energy plants could treat, more residual waste. Should we significantly reduce waste generation, the plants can be flexible and treat less waste. And then, of course, if after a long while it's visible that it's not economic anymore to operate the plant, then it's closed. It happened in Rotterdam some years ago. There was a decision, should we modernize the plant? It was up for modernization. Or is the economic situation not there any longer to justify it? And then it was shut down. So